Hey everyone, we're going to go ahead and do practice sheet number 2 of balancing chemical equations, and we're going to do problem number 7. So problem number 7 is a word problem, so we have to not only write out the skeleton equation, then we have to go ahead and balance it. So in this one right here, we'll go ahead and read it. Aluminum bromide plus chlorine yields aluminum chloride and bromine. So we have a type 1 compound here. For nomenclature, another type 1 compound on the other side of the arrow. We have chlorine on this, and we have bromine. So the big thing is, when we have two elements by themselves, we have to make sure and double check and see if they are diatomic. So let's go ahead and start off, and let's just go ahead and get started on this. We're going to have aluminum bromide. Well, since it's a type 1, we have to look at the charges. So let's look at the charge of aluminum and bromine. If we go to our monoatomic sheet, since it's type 1, we'll see aluminum is right here, which is a +3. And bromine, if we get over here a little bit, is right here, so it's a -1. So I have a +3 and a -1. So let's go ahead and get back to the question. So we have +3, a -1. They do not cancel each other out, so we're going to crisscross them. So that means I'm going to have 1 aluminum, but I'm going to have 3 bromines. To that, it's going to react with chlorine, okay, and this is going to be chlorine gas. Now, chlorine is Cl, okay, and that is going to yield aluminum chloride. Now, again, this is type 1. So we're going to go back to our monoatomic ion sheet, which is on page 13 of our packet, and we're going to find aluminum is a +3 and chlorine is a -1. So +3, -1, excuse me, they do not cancel out, so we're going to crisscross them. So the aluminum becomes 1, and the chlorine becomes 3. And to that, we ended up with bromine as a byproduct. Now, again, we're not done with the skeleton equation, because we always have to ask ourselves, if there is an element alone, like chlorine and bromine, they're by themselves, are they diatomic? So let's go ahead and go to our periodic table. And we said in our periodic table, there are 7 elements that are diatomic. They are nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So chlorine and bromine are diatomic. Now, they make a 7 again, but there's only 6 elements here plus hydrogen over here. So let's go ahead and go back to our thing, and we said, yes, this was. So we're going to put a 2 in there, and we're going to put a 2 right there for our bromine. So now we have our skeleton equation. It's not balanced. It could be balanced, but let's see if it is. So let's go ahead and put in our elements that we have on both sides. We have aluminum. We also have bromine. And we have chlorine. So I have aluminum, bromine, chlorine, aluminum, bromine, chlorine. So how many do I have on each side? By doing this, we're going to go ahead and say that we have 1 aluminum on this side, and we have 1 aluminum on this side. Bromine, I have 3 bromines on this side. So we're going to go back down here, and we'll put 3 in. And I look over here, I have 2 bromines on this side. Okay, chlorine, I have 2 chlorines on this side, and I have 3 chlorines on that side. So I have the same amount of aluminum, but I have different numbers of chlorine and bromine on each side of the periodic table. So we're going to go ahead and look at bromine first. Well, I look at this, and these numbers are close together. This one will always be odd. This one's always going to be even. I shouldn't say always odd. This is always multiples of 3. This is multiples of 2. So what's a number that each one can go into? And that would be 6. So if I change this to a number that equals 6 here, so I'm going to change this to a 2, and now I have 6 bromine. So if I put this back over here, and I'm just going to Ooh, don't want that. And I'm going to change this to a 6 bromine. Okay. But I also have 2 aluminum. Now I got to change bromine over here to make it 6. So I'm going to put a 3 right there. Okay. And now I have 3 times 2 is 6. So I'm going to put my 6 right there. Didn't change anything else. So now I did my aluminum. So I'm going to chase my aluminum. So I'm going to put a 2 right here. Put a 2 right there. So now I have 2 aluminum. But how many chlorines do I have? Well, I have 6 chlorine. So I have 2, 3 times. So I'm going to have 6 chlorine on this side. So I got to make this 6 on this side. So what times 2 equals 6? So I'm going to put a 3 right there. And that means that this changes to a 6. And so I have 2 and 2, 6 and 6, 6 and 6. Let's go ahead and do this again. I have 2 aluminum here, and I have 2 aluminum there. I have 3 times 2 is 6 bromine on this side. 3 times 2, I have 6 bromine on this side. As far as chlorine, I have 3 times 2 is 6 on this side, and I have 2 times 3 is 6 on this side. So we're already done. So our molar mass, our molar ratio is 2 to 3 to 2 to 3. Woo, what did I just do? Let me just go back here. Go back to this. So let's fix this. Okay, so we have 2, 3, 2, 3. So I have to put a 3 here. So I'm going to put a 3. Then I'm going to put a 2. And I'm going to put a 3. So 2, 3, 2, 3, 2, 3, 2, 3. I'm going to highlight that. Look at it. Can I reduce? Well, nope. I can't reduce anything smaller. So we're going to go ahead and make it bold. And we're going to go ahead and highlight it. So there's our answer. There's our balanced chemical equation. There's our molar ratio, which is going to be important when we do stoichiometry. So that's how we took a word equation, chemical equation, wrote out the skeleton equation, then balanced that skeletal equation to come up with a balanced chemical reaction. So there's number 7. Good luck with the last one. Nelson out.